People, they did it. They actually did it. They made a Frozen 2. Hello, Internet. And by internet, I mean 70 subscribers. And welcome to Speed Through Chemistry. I'm Tim, your host, and today on this video, we're going to be talking about how Elsa attempted to be like Jesus in the new teaser trailer, Frozen 2. If you haven't seen it, I'll put the link in the description, and if you don't want to watch it, then I don't care. So in the beginning, Elsa was standing on the shore of a beach, and she was just standing there in what seems to be the middle of the night. And I guess she was thinking to herself, what would Jesus do? And then she took off her coat and boots, took a couple steps back, and then just started running towards the ocean, and then she was running on the ocean. Look at this. When I seen this, I was like, wait a minute, what? No. Is this even possible with her magic ice powers? And after about watching this like 5 times, I had 3 main questions. The first question was, is it even possible to run across water using ice platforms? And the answer to this is yes. As long as the ice is 4 inches thick and about 18 inches in diameter, if you pause the trailer at just the right time, you can kind of tell that the platforms that she's running on are a few inches longer in diameter than her shoulder width. And the average woman's shoulder size is about 14 inches wide. And you can kind of tell that the snowflakes are at least 3 to 4 inches longer than her shoulder's width. And for my second question, how fast does she have to freeze the water so she can step on it? For this question, I had to figure out how fast the average person ran, which is about 10 to 15 miles. I assume she was running about 10 miles an hour in the trailer because from the first movie, she's lived in the castle all of her life. And she like hid in the castle, she never left. So I'm pretty sure she never exercised. And the average running ground contact is 160 to 300 milliseconds. I assume 300 milliseconds for her because again, I don't think she exercises. And the water freezes as soon as her feet touch the water. So it has to freeze in an instant. I googled how long is an instant, and it's basically the speed of light. So the water needs to freeze about 4 inches thick and 18 inches of diameter near the speed of light, which is impossible because the molecules in the water will heat up so much during the transition form of a liquid to a solid. They wouldn't even be stuck together anymore. Before it would even get to like 1% of the speed of light, it would just explode. So in reality, every time she took a step on the water and tried to freeze it, this would happen. And for my third question, how cold does she have to make the water in order for it to freeze that fast? There's no way I can calculate that because I suck at physics and overall math, and to be honest, I don't even know that much chemistry. But after doing some research, I learned if you get a cup of room temperature water, go outside to a temperature of negative 41 degrees Fahrenheit. I don't know why you would ever do that, but if you got a cup and you poured it out, the water would freeze before it hit the ground. Now that's pretty fast, but it's not the speed of light fast. I know because I tested it. But the water Elsa was running on was not fresh water, it was salt water. The freezing point, or also known as the melting point of fresh water, is 32 degrees Fahrenheit. And the freezing point of salt water is 28.4 degrees Fahrenheit. I'm going to explain why. So when water freezes, the water molecules of hydrogen and oxygen have bonded together into a crystalline structure of ice. The presence of salt makes it harder for the water molecules to bond to the ice structure. So for salt water to freeze before it hit the ground from a cup about 5 feet high, the temperature outside would have to be negative 45.4 degrees Fahrenheit, I'm guessing. Leave a like if you suck at physics, and leave a comment if you hate math. Go ahead and subscribe and hit the notification bell. And follow me on Instagram at Speed Through Chemistry. Alright, I don't know what I'm doing. Bye.